Sometimes with examples like this, you are going to be asked to use only Ohm's law and Kirchhoff's law, as opposed to, as you can see here, being able to use a divider law, whether it is voltage divider or it is a current divider. First thing you're looking for is, can I use Ohm's law anywhere? Can I use the law of V, which is voltage equals to I multiplied by R, which means I need to know at least two of those three to calculate the third. If you make a close examination here, you can see that right here you have the current that is passing through a resistor for which we know the value of. Okay, so if the resistor is 240 and if the current is 51 milliamps is 0.051 amps, then we can calculate the voltage. In this case, it's going to be V3 because the resistor is R3. All right, and in this case, you are going to find out that the voltage is 12.24 volts. Right, so what I'm saying here is that the voltage drop between these 2 points, this V3, is 12.24 volts, right? Now, what is important is to make a assessment of what we're looking at in terms of the relationship of the resistors to each other, because we want to know where is this voltage going to, whether it is going to be added to R2, R1, or what's happening. So for that purpose, let's go back to our nodes analysis as we worked on it before, and excuse me, let's make a little kind of node analysis. Here is one node, okay? Here is another node, the green node, and here is another node, which is a blue node. So you have three nodes. And if you have a quick look at the nodes green and blue, so between the node green and the node blue, you have a couple of resistors. You have resistor number 2 and you have resistor number 3, right? So that's between 2 and 3, which means that they are in parallel. That's the rule for parallel circuits, parallel resistors. If two resistors are sharing a node on one side and another node on the opposite side, then they are in parallel. All right, in this case, we also know from parallel circuit rules that we've discussed before that V3, sorry, we know that V3 and V2 are the same because the resistors are in parallel, and that's the rule for parallel circuit. So this is also going to be V2. All right. Now, are R1 and R2 in parallel? Well, they share one node at one end, but they do not share a node on the other end, which means that, they are definitely not in parallel, and they are also not in series, which is interesting to say. But there is something else going on. Right now, we can use Kirchhoff's law in this circuit, all right? In this loop, sorry, not circuit, in this loop. In this loop, what we have is the voltage, the EMF, electromotive force, and then we have the voltage drops. So what I'm saying is this. In that loop, we have 20 volts equal to V1 plus V2. That's Kirchhoff's law, Kirchhoff's voltage law applied to this circuit. And in this case, 20 is going to be equal to V1 plus V2, we just determined, is 12.24. Therefore, V1 is going to be equal to 20 minus 12.24, and that is going to be equal to 7.76 volts, right? So we have V1 equal to 7.76 volts. We have V2 equal to V3 equal to 12.24 volts. Now, if you just remove everything from here, you can notice that we can literally calculate the value of R1. R1 can be calculated from Ohm's law, being equal to voltage 1 divided by the current I1. We both know, we know both the values, so it is going to be 7.76, we just calculated that, divided by 0.657 amps, which is 657 milliamps, and that is going to give us the value of R1. Calculation adds up to 11.81 ohms. So that's the first thing we needed to calculate. Well, how about R2? R2 would be V2 divided by I2. Is this something we can calculate? We don't know this. We know this. We don't know this. Well, okay. Can we calculate I2? Well, in a quick look here, I1 is going in here, and it is going to be divided into two branches, right? So again, I1 is going to go here and here. So I1 is being branched off, meaning that intuitively, you know, I1 equals to I2 plus I3. That's what it means. So 0.657 amps are going to be equal to I2 plus I3 being 0.051. Therefore, I2 is going to be 0.657 minus 0.051, and then I2 is going to be equal to 0.606 amps, or 606 amps. I can apply that here. So V2 being 12.24 divided by 0.606, and the answer is going to be added up to, answer is going to be added up to 20.19.8, so I would say 20.2 ohms, and that's R2.